Hi, in the last few videos I did a review and teardown of UNI-T's MSO2304X mixed signal oscilloscope. And as promised, in today's video we'll take a look at an MSO3000X series oscilloscope from UNI-T. Here on the workbench is an MSO3054X. It has 4 channels, 500 MHz analog bandwidth, and 5 gig samples per second maximum sampling rate. There's another model from the MSO3000X series, and that one is the MSO3034X. The only difference between the two model numbers is the oscilloscope bandwidth. For the MSO3034X, the analog bandwidth is 350 MHz. It appears that UNI-T somehow changed the model numbering convention between the 3000X series and the 2000X series. If they follow the same convention, this scope should be MSO3504X instead of the MSO3054X. Not exactly sure why they did that. Anyway, the MSO3000X series actually share a lot of commonalities with the MSO2000X series. Besides the bandwidth difference, obviously the most prominent difference is the color of the case. As you can see here, the MSO3000X has black exterior. Another obvious difference is the probe interface. As you can see, we have these contacts for active probes. In addition to the standard probes, the MSO3000X series also supports the UT-PA2000 active probes, but the probes are sold as an option. The included probes are the UT-PO7 500 MHz ones. And speaking of the probes, let's actually take a look at the included accessories. Let's open it up. So as you can see here, we have the certificate of calibration, and also this one tells you the instruments used to calibrate the scope. And again, the date of calibration is fairly recent, in November 2024. In the box you can see that we have these probes as I mentioned earlier, and these are the UT-PO7A, and these are 500 MHz. You can see that they look pretty much the same as the other probes, but of course these are of higher bandwidth. And also we have a BNC to banana clips cable, of course a power cable, and BNC to BNC cable, and USB 3 host cable. So everything pretty much is exactly the same as supplied with the MSO2000X series. And yes, you do get 4 probes, 1 for each channel. Combing through the specs, I can see some other differences as well. For example, the maximum memory depth of the MSO3000X series had increased to 500 MB points versus the 100 MB points in the MSO2000X series. The segmented memory in the MSO3000X series can store up to 250,000 frames of real-time waveform data versus the 125,000 frames in the MSO2000X series. And the 3000X series also supports Wi-Fi connectivity, whereas the 2000X series only supports Ethernet. Like the 2000X series, the 3000X also supports logic analyzer function, but you will have to purchase the UT-M15 logic analyzer pod in order to use this functionality. The logic analyzer on the 3000X series does have higher memory depth, 250 MB points versus the 100 MB points on the MSO2000X. Other than that, the logic analyzer specs between the 2000X series and the 3000X series are pretty much identical. They both support 16 digital channels with a maximum sampling rate of 1.25 gig samples per second and a minimum detectable pulse width of 800 picoseconds. The built-in function generators have the same specs as well. It has 2 50 MHz 16-bit channels and has a sampling rate of 250 megasamples per second. It also supports arbitrary waveform generation, but that is an option, not enabled by default. And just like the MSO2000X series, the ADCs used on the MSO3000X series are also 8 bits. The 3000X also supports the enhanced resolution or ERES mode up to 12 bits, but of course with reduced bandwidth. For up to 9.5 bits in ERES mode, there is no bandwidth penalty, but you do get slower triggering rate. In certain measurement scenarios, this may be a good compromise without having to sacrifice the bandwidth. I should mention that UNI-T just released the MSO3000HD series, and the HD series has 12-bit hardware ADC with enhanced resolution up to 16 bits. Although it appears that the maximum sampling rate in the HD series is only half of what we have here in this MSO3000X series. Because I did a thorough review of the MSO2304X already, and most of the features are the same on this MSO3054X, so I'm not going to repeat those common features. I would strongly recommend you to watch the MSO2304X review video first. I will include the link to that video in the card and also in the video description below. Alright, it's time to power on the unit, but let me actually remove the protective film first. Wow, the first thing I noticed is that the fan in this MSO3054X is actually a lot quieter than the one in the MSO2304X. I would be curious to see what the deal is. Maybe UNI-T decided to use a different brand. We'll need to confirm that in our teardown later, maybe in the next video. Alright, now the scope is fully booted up. Actually, you know what? Let me do a power on test comparison with the MSO2304X and the 3054X side by side. Alright, so now I have both scopes out here. Let's do the power on test again. Yeah, the fan in that MSO2304X is definitely a lot noisier. So the boot up time of these two scopes are fairly comparable, as you just saw. Now, the MSO2304X was probably ever so slightly quicker. So from this exercise, it tells me that underlying hardware in terms of FPGAs and application processors are pretty much the same between these two units. Of course, the front end will likely be different, and we will verify that when we open it up. Because the additional memory depth offered in the 3000X series, I would expect it will have more memory on board, of course. But the ADCs would be identical, as the 3000X series also has 5 gig samples per second sampling rate, just like the 2000X series. And by the way, the lighting effects of the buttons are different between these two models as well. The edges of the buttons on the MSO2000X series are translucent, whereas on the MSO3000X, only the letters are illuminated. Let me know which style you prefer in the comment section below. Alright, I will power them off, and let's concentrate on the MSO3054X. And you can see that timing for powering off these units are pretty much identical as well. Anyway, the first thing I wanted to verify is the 500 MHz bandwidth claim. And for that, I'm going to use my HP8642B, which is humming in the background. Let me actually first change the input impedance of the scope to 50 ohms, as that is what is expected by the signal generator here. So let me come here, and you can see that right now it's 1 meg, so let's change to 50 ohm. And also I'm going to enable a couple of measurements. So for that, I'm going to come here, let's do measure, and we will first enable the counter. Let's add another one. Let's come here, let's do measure, and I'm going to add the AC RMS full scale, so that will give us the RMS value across the entire range. Let's do amplitude minus 6.5 dBm, that should be approximate, and let's acquire signal. So right now we're at 102 millivolts. Let's actually reduce it by 0.1 dBm, maybe 0.2 dBm. And you can see right now we get roughly 100 millivolts. And because this is a 500 MHz bandwidth scope, I'm going to increase the frequency 100 MHz at a time. So let's take a look. Right now it's 100. Let me come here, frequency. Let's do 200. 3, 4, 5. So let's zoom in a little bit. You can see that at 500 MHz we're at 920 some odd millivolts, which is definitely above the 3 dB bandwidth. Of course, we can expand the horizontal here. And by the way, on this MSO3054X, we actually have a 500 picoseconds horizontal, whereas on the MSO2304X, it was down to only 1 nanosecond. So that's another difference. Okay, so now let me increase the frequency 10 MHz at a time. Let's see what the frequency bandwidth is. 550 MHz. Still going. 600 MHz. So right now we're at 650 MHz. Now you can see that the amplitude dropped to roughly 71 millivolts, and that is our 3 dB bandwidth. And let me enable channel 2 to see if we have any impact. Yeah, there's a little bit impact after we enable channel 2. And remember, we know from the teardown of the MSO2000X series, channel 1 and channel 2 share an ADC together. In fact, there are 4 ADCs interleaving and forming that 5 gig samples per second sampling rate. For channel 3 and 4, those 2 channels share another set of the 4 ADCs. So I'm pretty sure that's exactly the same in this MSO3000X series. Of course, we'll need to confirm that in our teardown. So you can see here, with channel 1 and channel 2 both enabled, the sampling rate would drop to 2.5 gigasamples per second, as you can see up here. And the signal quality degraded somewhat at the highest bandwidth, which is to be expected. Because the sampling architecture is the same on this 3054X compared to the 2304X, so I'm fully expecting we can push the frequency a lot higher. So let's do that. And now I'm going to 700 and 800. Let me increase the amplitude. $900, and we'll go to 1 gigahertz. So now we're at 1 gigahertz. You can see that we are reading the frequency correctly. Of course, the magnitude dropped significantly, but we're getting the stable waveform. So let's go to 1.1 gigahertz. And now we're at 1.1 gigahertz. Let's see if we can adjust the scale. So right now we're at 1.1 gigahertz, and not surprisingly, that was the same frequency we could measure on MSO2304X. And of course, at this frequency level, if I enable channel 2, you will see the signal quality would drop even further, and that's to be expected. So the performance of this scope is definitely impressive. And with what we just saw, I'm pretty much convinced that UNI-T is using the exact same ADCs in this MSO3054X. And now I'm using the Avalanche pulse generator to verify the write time here. And because we have a 500 picoseconds per second horizontal scale, we can actually expand the pulse even further. You can see that. So let's take a look at the write time here. And let's enable the cursor here. So we're reading roughly 800 picoseconds. Of course, that's slower than the 500 MHz, but that is not because of the scope. As we saw earlier, the scope was able to handle much higher bandwidth. And we have seen that with the sinusoidal signal coming in, the bandwidth is well above the 500 MHz mark. We know that the write time of the Avalanche pulses are in the hundreds of picoseconds range, and maybe we are actually approaching that limit. As you can see here, now the measured write time is actually a little bit slower than what I expected. So I would say that the measured results here is definitely a result of the limitation of our pulse generator, not the scope. As I mentioned earlier, except for the added bandwidth and the onboard memory, most of the functionalities are identical to those on MSO2304X, which I had done an extensive review on. And in that video, I demonstrated the waveform search function using the segmented memory to capture sparsely occurring waveforms, the ultra-phosphor display, mathematical functions, the XY mode, FFT waterfall display or spectrogram, using the Bode plot to characterize filter input and output amplitude phase relationship, and using the oscilloscope for protocol decoding. If you haven't watched that video yet, I'd strongly recommend you checking it out, as it would help you understand the capabilities of this MSO3054X as well, since those features are pretty much identical on this oscilloscope. One of the features both of these scopes offer is the ability to do power analysis. This is actually a very cool, useful feature if you're doing switching power supply design or repair work. Using this function, you can perform analysis on the power quality, harmonics, and even measure the surge current. So let me bring up that menu item. Here is the power analysis, and we can enable that. And here is where the help comes in handy. If you don't know how to wire things up, you can come here and press on the wiring diagram. You can see that basically you put a current probe on the input side of the power supply and also measure the voltage waveform at the same time. When I did the review of the MSO2304X, I didn't do this test because I don't have a current probe that can be used without an oscilloscope. The only current probe I have is the MIXIC CP503, which requires the MIXIC probe interface, which obviously would not work with the MSO2304X, and is not compatible with the probe interface on the MSO3054X either. So in order to test this feature, I decided to use a voltage probe with a shunt resistor to perform the current measurement. And that's what I'm going to show you here. Okay, here is the setup. I had modified a small switching power supply and added a 10 ohm resistor in place of the inline fuse so that I can monitor the current via the differential probe. Anyway, I have two differential probes. I'm using the DP113 to measure the AC input voltage and the DP750-100, which is connected to the scope right here, to measure the voltage across the shunt resistor so that we can derive the current. The output from the switching power supply is roughly at 13 volts, and I'm drawing it down with a mini-wire electronic load. Currently is drawing around 1 amp. And by the way, using differential probes is crucial when measuring live AC circuit, as the oscilloscope is mains earth referenced. Let me just briefly show you the channel configuration here. Channel 1, that's our voltage channel. You can see that we're configuring this to 500X. That's the setting on the differential probe, and we set it to AC coupling. For channel 2, we set it to be probing current, and I did some calculation. The probe right now is roughly at 200 millivolts per amp. That's given our resistor value and also the setting of the attenuation. So that's our probe settings. To the left side, that's the waveforms of the input voltage and current. This waveform is very typical for a switching power supply that is not power factor corrected. On the right side, that's the power quality information. And just by enabling power analysis, you can see we already have a lot of information displayed here. And in the captured information, you can see we have the voltage RMS, the crest factor, and the RMS current, and power factor, so on and so forth. And let's see what else we can measure here. So let's come to the configuration manual. You can see right now we're displaying the power quality. We can change it to harmonics. Let's turn it on. And let's apply. And after we enable the harmonics feature, you can see we have the measurement in the background. And we are measuring according to some standard here. Of course, you have different standards to select from. And here in the measure results, you can see the total harmonic distortion, and of course, the different harmonics of the current waveform. And you can see here is the FFT plot. According to what we're seeing here, you can see that this power supply actually passes the standard, and we can identify all the harmonics values of the current waveform. Now let's briefly take a look at the inrush current. So for the inrush current measurement, I have turned the type to inrush current. And let's apply. Turn off the power supply. Yes, it's off. Next step. Turn on the power supply. Okay. And press next step. And you can see that we have measured inrush current here. It is at 3.3 amps. I have shown the network connectivity of the MSO2000X series, which is fantastic, as you can remotely control the oscilloscope. But the MSO2000X series only supports LAN connection, so you'll have to connect via an Ethernet cable. The MSO3000X series added the Wi-Fi support, so you can connect to your network wirelessly. So that is what I'm showing you right here. And you can see here, to enable wireless, which I have already enabled, you press at the bottom here. You can see that Wi-Fi is on, is connected. And then you come back to the utility, you can see the Wi-Fi here. Let me press on it. You can get the IP address, which I have, and then I put that into the browser window. Now I'm connected. So let's actually connect to the oscilloscope here. And you can see that we're displaying the waveform that is currently on the oscilloscope. Of course, you can control your scope directly from the computer. So let's take a look here. Let's change the waveform here. Let's go to generator. And let's change it to, let's say, a sinusoidal. And you can see we changed to sinusoidal. And we can come here, we can change the horizontals. And, of course, everything changes accordingly. Of course, just like the MSO2000X series, you can also hook up an external monitor, which I have done here. And to me, the convenience factor of the Wi-Fi support is huge compared to the Ethernet on-link connection found on the MSO2000X series, as it reduces clutter on my workbench and makes the MSO3000X series more portable. Another feature I find quite convenient is the ability for you to configure the shortcut menu on top of the screen here. You can change the default items up here and tailor it to your needs. And let me do a quick demonstration. So come here, I wanted to add this menu. For example, I wanted to add the segmented memory, as that is the one feature I use very often. So I move it to the top here. Immediately you can see that this icon appears on the top of the screen. Of course, we can add other things as well. For example, I wanted to also add the decoding capability here, and so on and so forth. And that pretty much wraps up the review of this MSO3054X. Overall, it's a nice upgrade to the MSO2304X I reviewed a few weeks ago. If budget allows, going for a 3000X series scope definitely will future-proof your investment. Anyway, I hope you enjoyed this review. If you liked it, please remember to give it a big thumbs up and don't forget to subscribe to this channel for more videos like this in the future. Your participation makes videos like this possible. Thanks for watching, and I will see you next time.